Hi everyone, I am Shweta, Assistant Professor from Artificial Intelligence and Data Science Department at Kalanya Karunanidhi Institute of Technology, Coimbatore. Now we are going to talk about one of the most important concepts in data structure, that is stack. First, what is a stack? A stack is a linear data structure that works on a principles like a LIFO. That means last in and first out. This means the last elements you insert will be the first one you take it out. Imagine a stack of plates. You always remove the top plate first, right? Why are stacks important? Stacks are everywhere in computing. Like they are used in functions calls, undo, redo operations, memory management, expression evaluation, and more. Without stacks, many programming and system operation wouldn't be possible, right? And then the next thing is what we learn today. Like we will start with a definition of the stack, then explore a stack operations like push and pop. Push means adding, pop means removing. Okay, we will also look at the real life examples to understanding where stacks are used in daily life in computer applications. Finally, we will see how to implement the stacks using arrays and linked list. And by the end of the session, you will not only know what is the stack is, but also how to use it effectively in your programs. And the next slide is what is stack. We already know a stack is a simple linear data structure where elements are arranged one after another. It works on a rule called LIFO, that means last in first out. This means the item that goes in last and will come out first, right? And the example is think about a stack of plates in your kitchen. You keep adding plates on top, and when you need one, you take the top plate first, right? You never take the plate from the bottom. That's how the stack works. Okay, the important terms are push, pop, and peek. Push means adding an item to the top of the stack, and pop means removing the top item from the stack. A peek means looking at the top item without removing it. So the stack is like a file where you can work on the top. And the next thing is, now let's talk about the main operations we can perform on a stack. Like there are three important ones like push, pop, and peek. First thing is push. Push means simply adding a new item to the stack. We always add it onto the top in the code. You will see a stack of plus plus top equal to value. This means we first move the pointer top to the next position and we place the new value there. And the second thing is pop. Pop means removing the top item, and the code is value equal to stack of top minus minus semicolon. We first take out the value at the top and then decrease the top pointer to move it down. And the third is peek, also called top. This operation just look at the current top element without removing it. The code is value equal to stack of top semicolon. So in simple words, push adds and pop removes and peek just show what's on top. These are the three are the basic building of the stack. And the next thing is, now we know how to add and remove the items from the stack. We also need to check the status of a stack. That's where the three checks comes in, like is empty, is full, and is size. First thing is empty. This tells us the stack has no elements. The condition is if at the top of equal to minus 1, it returns true. Here top equal to minus 1 means nothing has been pushed yet, so the stack is empty. And the second thing is full. This checks whether the stack is completely filled. The condition is if top equal to size minus 1, it returns true. For example, if the size is 5, last element is index 4. So when the top reaches 4, then the stack is full. And finally size. This means tells the how many elements are currently in the stack. The formula is top plus 1. For example, if top is at 2, it means we have 3 elements at position like 0, 1 and 2. So remember, Is empty checks if there is a nothing, is full checks if there is no spaces left, and then size tells you how many items are inside. Let's see about real life examples in stack operations. Stack are not just a theory; they are used to everywhere in real life and programming. Let's see common examples like first thing is undo and redo in editors. When you type word or text editor, every changes you make is stored in a stack, right? If you press undo, the last change is removed first, right? Exactly how the stack works. And the second thing is a function called stack. When your program runs, each function call is placed on a stack. When function finishes, it is removed and control goes back to the previous function. And the third thing is balancing parentheses. When you write expressions like a plus b star c minus d, a stack is used to keep track of opening and closing brackets to ensure everything is balanced. And the fourth thing is backtracking problems like games, puzzles, and algorithms like maze solving used in stack to backtrack on the try different paths. And finally, expression evaluation in calculators and compilers. Stack helps to evaluate the mathematical expressions and convert them into the formats like infix, postfix, and prefix. So stacks are behind many features we used daily without even realizing it. And the next thing is stack implementation. Finally, let's how the stack is actually implemented in our programs. There are two common methods using arrays and using linked list. First thing is using arrays. In this method, we can create a fixed size array. This means a stack can only hold a limited number of elements. Like it is simple and fast because accessing elements in an array is quick. But the limitation is that that once it is full, you can't add any more items unless you increase the array size manually. And the second thing is using linked list. Here the stack is built using nodes that are connected to each other. Each new item is stored as a node and linked list to the previous node. The biggest advantage is dynamic size. You can keep adding items as long as memory is available. It's more flexible than arrays but slightly more complex to implement. And the next thing is common stack errors. The first thing is stack overflow. Imagine you have a stack with only 5 slots. You have already added 5 items. Now let's if you try to add one more item without checking, like boom, you will get a stack overflow, right? It's like filling a book beyond the what your shelf can hold. You will either damage something or getting an error. So always check if there is stack is full or before pushing anything new. Okay. And the next thing is the stack underflow. Now what happens if you try to remove something from the empty stack? Like let's say that the stack is already empty and you will can call the pop function. There is nothing to remove. That's called the stack underflow. It's like trying to take the plate from the empty tray. You reach out but there is nothing there, right? So again check with this is empty function before popping. The key lessons here is simple. Always do your safety checks like use is empty function before popping and use is full function before pushing, especially in arrays based stacks.